This is the second lecture on divisibility. We're going to give some rules for divisibility, and we'll mention two principles. Then we shall use these two principles to explain why Euclidean algorithm works. Let us recall what we have done in lecture 1. Over there, we gave rules for divisibility by 2, by 5, by 3, by 7. And we're going to do the same, but using a different example. Let us try 11. Now, I have a number here, 726. And I ask whether this number is divisible by 11 or not. So there are two ways. One is breaking up 10, and the other one is making up 10. Let me try the breaking up 10 first. Yeah. So I write 700 as 7 times 100, and 20 as 2 times 10, and then plus 6. Yeah. I'm going to break up the 10. I'm going to break up the 100 here. I think breaking up 10 into something 11 is not difficult. As I can see, all I need to do is 11 minus 1. I have plus 6 here. See, can you see that 11 minus 1 give me 10? And 11, of course, is divisible by 11. Now I have 100. I have a bit of problem here. I just wonder, how do I break it up? Yeah. Let me write it down first. Say 99 plus 1. As you can see, 99 is divisible by 11. And plus 1 give me 100. Yes, I managed to break up 100 into something divisible by 11 and 1. I did not try 101, yeah, because 101 would not work, because 101 minus 1 give me 100, but 101 is not divisible by 11. Why do I want to insist on divisibility by 11? You'll see in a minute. Yeah. Now let me collect all the numbers divisible by 11. So 7 times 99, this is divisible by 11, plus 2 times 11 again, this is divisible by 11. I miss out the 7 here, so it's plus 7. I miss out the 2 here, minus 2. Please note that this is minus and not plus. Whereas this is plus, this is minus. And here is plus again. So look at the numbers on the left-hand side and number on the right-hand side. As you can see, this is divisible by 11. This is also divisible by 11. So the sum is also divisible by 11. Then whether the whole number is divisible by 11 or not depends on this sum. If this is also divisible by 11, then I can claim that since both are divisible by 11, so the sum is also divisible by 11. Let me check here. And this is easy, because 7 minus 2 plus 6 is equal to 13 minus 2 is 11. So indeed, this is divisible by 11. So I know that 726 is divisible by 11. Can you see how I get this number? This number is precisely the digit of the number 726. The only difference is that I would add 6, minus 2, and plus 7. And you see that this rule also works in general. Let me at least summarize for this 3-digit number first. Then we do it for 4 digits later on. So for 3-digit number, if you want to check whether this number is divisible by 11 or not, what you do is you add up all the odd digits and take away the even one, and the outcome is divisible by 11, then you claim that the number is divisible by 11. Otherwise, it is not. For example, you can check very easily that 7 to 7 instead of 6, then you end up with a 7, end up with a 7, then you end up with a 12, so it is not divisible by 7. So we say that 7 to 7 is not divisible by 11. Now we are going to try a 4-digit number and check whether this 4-digit number is divisible by 11 or not. Before we do that, let us discuss a little bit about how you break up 10, you break up 100, and you break up 1,000. Yeah. I think we've done it for 10. To break up 10, you write as 11 minus 1. And then I have two numbers. One is divisible by 11, and the other one is 1. For 100, you can think of it this way, that actually this is 10 square, right? And 10, you can think of it as 11 minus 1 square, yeah. And you can expand it. So the first term is 11 square minus 211 and plus 1, yeah. So what I'm saying is that this is equal to something and plus 1. And this something is divisible by 11. Now let me go to the 1,000. 1,000, you can think of it the same way as this is 10 cubed. And then you can again think of this as, if you want to write it in longhand, then you find that you will have to multiply them out and you get 8 terms. Yeah. So you go and check that every term will contain an 11, because if you start from here, you times 11 times 11. You start from here, 11 times 1 and times 1. So most of the term will contain an 11. But there is one that doesn't. Which one? That is the one that you multiply this and this. Yeah. So what I'm saying here is that what you end up with is something which is a sum of many terms, each of which is divisible by 11, and with the additional term, minus 1, and minus 1, which give you minus 1. Yeah. Let us review what we have done. Can you see that if it's 10, then it's 11 minus 1. This is minus. When it is 100, then it's something plus 1. Of course, we can figure out what this is. This will be 99. And sure enough, 99 is divisible by 11. And if it is 1,000, you can break out into something minus 1, which will give you 1,000. What do you think this number is? Oh, that's easy. This must be 1001. And this is how we get the 1001, which we're going to use for checking the divisibility of a 4-digit number later on. Now we are ready to try it on the 4-digit number. Here's the number 1452. And we ask whether this is divisible by 11 or not. Yeah. And we do the same thing. We'll break it up. Yeah. So the first one is 1 times 1,000 and 4 times 100 plus 5 times 10 and then plus 2. I think we have done it for 10, we've done it for 100, we haven't done it for the 1,000, but we have just learned that 1,000, you can break it up into 1,001 and minus 1. And 1,001 is divisible by 11. Let us do that. Yeah. So then this is equal to 1 times 1,001 minus 1 plus 4 times 99 plus 1. This we have done it before. And then 5 times 11 minus 1 and plus 2. And we repeat the same thing. You collect all those numbers that is divisible by 11. Remember that 1001 is divisible by 11. And 99 is also divisible by 11. Of course, 11 is divisible by 11. See, I have all these terms divisible by 11. I collect them together. Then next, as you can see, this is minus 1. Please note the sign is minus. And then plus 4. And minus 5. And plus 2. Can you see again, very interestingly, that you add up and minus all the digits. What you have to note is that you add up all the odd digits and minus all the even digits. And the same argument applies. Since this is divisible by 11, to check whether 1452 is divisible by 11 or not, all we need is to check this number. And you can add it up and see what happened. Minus 1 plus 4 minus 5 plus 2. As you can see, this is exactly 0. Of course, 0 is divisible by 11. And therefore, I can claim that this number is divisible by 11. Now I take a closer look. I notice that I can do that for the odd digit, add them up, and add up the even digit and take the difference. Now let me make the bold step. Now I claim that I have a rule for the divisibility by 11. That is, you add up all the odd digits and you add up all the even digits and you take the difference. If the difference is divisible by 11, then this number is also divisible by 11. And you can check for a larger number and see whether it works or not. So here is the rule. So we have constructed a rule for divisibility by 11 using the method of breaking up 10. Another method is making 10. Let us try it again using this number, 1452, and see whether this is divisible by 11 or not. And this time, we are going to make up 10. Now, you write it as 1450 plus 2. The idea is you want to minus something or plus something in such a way that I get a 10 out of this. And don't forget that whatever I add or minus must be divisible by 11. That's not too difficult. As you can see, all I need to do is minus 2 times 11. You don't need to plus. Sometimes you plus, sometimes you minus. You just get a number so that you get a 10 in an easier way. Check it again. So if I take the 2 out of the bracket, I get 1 minus 11. I get minus 10. So I have a 10, right? Don't forget that you cannot minus anything at will. So you have to plus 2 times 11 so that you still have the equality. Now let me work out the detail. So this will be plus, oh sorry, this is minus. Minus 2 times plus 2 times 11. As you can see, there is a 10 here. So I have 145 minus 2 times 10 and plus 2 times 11. Let us look at the number again. This is divisible by 11. So if you want to check the number, whether it is divisible by 11 or not, you check this. And we know that 10 is not divisible by 11. So in other words, all you need to do is to check this number. And you can work it out. So 145 minus 2 is equal to 143. And you can see that this is divisible by 11. Let us look back. What I have done here is in fact just take the unit digit and subtract from the other digit. So this is the rule. How do you find out a number is divisible by 11 or not? All you need to do is take the unit digit and subtract it from the rest. If you get a number which is divisible by 11, that's it. This number is also divisible by 11. If you like, you can check it on this again. Suppose we are not sure whether this number is divisible by 11 or not. How do you check using the previous rule? You take the unit digit, which is 3, and you subtract, and indeed you get 11. So yes, 143 is divisible by 11. Now I have a new rule for divisibility by 11. So now we have two rules for divisibility by 11. You notice that in the process, we actually make use of two principles. The two principles are as follows. Now, if you have two numbers, say for example, this number plus this number, if you want to check whether the sum is divisible by, in this case, 11 or not, you check this number. If it is divisible by 11, then you check this number if it is also divisible by 11, as it is the case here, then the sum is also divisible by 11. I repeat that again. If you have a sum, if both numbers are divisible by a given number, then the sum is also divisible by the given number. This is the first principle. The second principle is you look at the product of two numbers. You look at this one. So you have a product, this times this. If you want to check the product is divisible by a certain number or not, in this case is 11, you check either of them. If one of the number is divisible by 11, for example, divisible by 11, then so is the product. So I repeat that again. If you have a product, if either of the number is divisible by a given number, then so is the product divisible by the same number. And this is the second principle. We are going to use both principles later on.